那我不太完全懂公司的这个干嘛。
So my name is Xiao Yang, and research manager, research team. So our passion to be actually this event was suggested by himself. He said, "Oh, I have an idea what you can do in Taipei. Oh, how about DNA, a technical roadmap DNA, ANA."
Is this being recorded, by the way?
Yes, yeah.
Okay, so I guess that, great. I won't make fun of some of the other crazy speakers too much then.
Research.
Yeah, this is research, yes.
So it's a small group. We focus on romance. So we collected some questions, but I think the questions are also in your mind. So today we start with people asking random questions.
Yeah.
And the romance question first. Yeah. So next, Vitalik, and anyone want to share some insights? Or I can start with the speaker.
First of all, you recently replied a tweet about what you think about the cross-chain. What EIP will improve the cross-chain interoperability, and can you kind of explain what do you think each EIP played in the cross-chain component?
Right. Yeah, no, it's a good question. So the way that I think about the high-level goal, right, is that we basically want to try to get all of the benefits of Ethereum being an ecosystem that is a unified ecosystem. It does sharding, everything is Ethereum, everything feels like Ethereum, but at the same time still having these different layer twos that are trying different things with security models, execution, environments, and so on, right? And so the high level question is basically what is the 80-20? What are the few things that we need to standardize to really make the highest impact in terms of solving the problems that we have now, which is basically the ecosystem looking like 34 different blockchains. And so the ones that I've been focusing on are the one at the top of that list, right, was ERC 3770, which is basically address formats where the address includes, the chain or and then have the address after it. And there's actually some discussions that's still going on. There's people that have been very recently proposing different versions of 3770. There's things do you put the chain at the beginning or at the end? There's do you do this in off-chain registry, or do we just keep the registry ENS? If you want to have an address that's valid on multiple chains, do we make a standard for that? So there's some discussions for this, right? But the underlying idea is basically that and if you give someone an address, that by itself should contain the information that they need to actually pay you in a way where you actually get the money, right? And that should be true for a person and for an application. So 3770 is just an address format, and if that just gets adopted, then that's a really big part of the whole problem solved already, right? Because especially if you also include wallets being able to automatically do a cross-chain set with yours. And if you put in an address and you're simply send the address that's on a chain where you don't have any assets yet, right? And we get to the point where wallets can actually just understand that they're supposed to do a cross layers to transfer and just process that transfer automatically, right? Then that already solves a lot of problems, right? So that's part one. The next part I think is so we talked about I brought up 7683, which was a standard for basically creating orders. So like basically a standard for like doing a thing where if you're moving points from chain A to chain B, then like on chain A, you put your points into a smart contract, like a lockbox contract, and then the rules of that contract say whoever submits a proof that they were the one that sent me like some other points on chain B. And like if that proof comes like 1 week later, that's okay. Then they can get the points, right? So it's like basically like limited orders, but going cross chain. I think I've been talking to some wallet people. There have been people who proposed like some different alternative ideas, right? Like one of the alternative ideas was instead of restricting it to assets, like maybe they can be a call instead. So like you can basically like on one chain say, I'm going to give a bounty to whoever processes this call on some other chain. And like that's nice because that also lets you do things like only have gas on one chain and then still be able to send transactions anywhere. But then there's like still the question of what do we actually need to standardize, and like what actually needs to be left to like individual wallets, right? And so, like, the way that I think about this, right, is that, like, what I don't want to see is I don't want to see, like, 10,000 different applications having to, like, all do, like, custom code, bring in custom libraries that, like, interact with some kind of, like, centralized intermediary to do trading, right? And I think, like, there's probably more minimal ways to do it where you just make a standardized, Web3 API call that just says, like, I want to do this cross-chain thing. And then it could be done through 7683, it could be done it could be done some other way. So I think there's like still some discussion there. I think the thing that I want to focus on, right, is basically like the top level goal, right? And the top level goal is basically that users, from the point of view of either a user or from the point of view of like a dApp, like JavaScript code, it should just look like, like the concept of a cross-chain operation should just be black box, right? So that's the goal there. Then the third one I think in the list was 3668, right? And that's like the cross-chain, like proof verification, right? So the idea there is basically that like we have right now we have L1, and we know how to access we know how to prove things on L1. But let's say you want to prove like some piece of state on sub L2, and there's like a few different reasons why you might want to do this, right? So one reason is if let's say you have an ENS name, and like let's say you want to make your own, like you have your own application, and your own application is like built on top of ENS, but you want to have like some subdomain, and you want to issue subdomains on your own layer too, right? Then people should be able to like actually do the ENS resolving, even if they don't already have like locally running custom code that like isn't a node for that layer too, right? And so what 3668 does is it's like a standard where an L2 can define a read function, and the read function just like takes as input the local proof, and then it verifies the local proof. And that's like completely abstracted, right? So like if the layer 2, if it wants to use Merkle Patricia trees, they can. If they want to use Merkle trees, they can. If they want to use Poseidon, they can, right? Like completely abstracted. Like basically from a user's point of view, what you get is like you can resolve things like ENS names on any layer 2, even if you don't already have code that supports that layer 2, right? So the initial motivating use case was like this is a way to steal ENS. But then the thing that we had to realize, right, is that if you have that, then you can also use this to make a client for any layer 2, right? And so if you basically, like if you have a light client for Ethereum layer 1, right, if you have like something like Helios, which like uses sync committees, verifies the header chain, then you can verify Merkle branches, and so you can verify anything on layer 1. But then what's used on layers, right? Like what we don't want to see is like a world where layer 1 is like super decentralized and making a lot of sacrifices to make layer 1 decentralized, but then for layer 2, where like everything happens, you just have to trust RPCs, right? And so the idea is that like realistically, you still use RPCs, but then RPCs can reply to a call and they can provide proofs, and you can actually use the on-chain contract of the layer 2 to verify those proofs, right? So you get like that trustlessness. And then like to me, the longer term goal is basically that, like, I think, like, I want to see a world where creating a new layer 2 is permissionless. And what I mean by that is, like, obviously you can make a layer 2 now, but I think there should be some base level of functionality that your layer 2 can just have automatically, even if you don't talk to anyone, right? Even if all you do is you just like deploy a contract, register on ENS, deploy a read function, like that already gives you some basic information that you need to like be able to read and write to that layer 2, right? So, like, I think this is one of the, basically, if you step back again, right? If you ask the question, if layer 2s did not exist, and instead, we had, like, let's say the 2017 sharding vision, right? And like Ethereum had 1,024 shards, and let's say that different applications were on different shards. Like, what are the basic properties that you would still have, right? And like basically the problem, one is you should be able to write, like you should be able to send transactions trustlessly. You should be able to read trustlessly. You should be able to like pay yes, right? So like those three things are basically trying to achieve like that. And then after that, I think I had like more complicated topics like keystone wallets and long-term layer 2 stuff. But I think those are like longer term discussion.
Okay. Yeah. So very prevalent question when you mentioned the EVM and cross chains. Right? I remember like 5 years ago, people still don't treat EVM chain as
Right.
like, oh, you're EVM chain, you're not.
Right.
Yeah. But now like people view EVM chain is related to EVM, but EIP can be part of this
Right.
EVM stuff.
Yeah.
Do you think EIP can go beyond EVM? Like, for example, the cross chain thing.
Right.
I can use this lot.
Right.
The same letter, just put like I'm asking because like recently there's some innovation about the finger app, like fan, passive fan, open fan, love dimensioning like link. And they'll do very specific the particle chain
Right.
can be used. And they unfortunately don't allow other people to use other chain. Like link is only example. And do you think EIP should go beyond this here? Even if you're even if you're not EVM.
Right.
But since we have the standard, you can say, hey, whatever they will happening.
Right. I mean, I guess the way that I see this is like I see there as being like different, like concentric links of standards that it makes sense to try to like make it support. Right. So like if you think about like addresses, for example, right? Like I think. Like I actually don't think there is much value in trying to like extend ERC 3770 so that it also covers Bitcoin. And the reason is basically that like actually the Bitcoin world already has their own standard for like what addresses look like, for what addresses on different and like Bitcoin derived chains look like, and like the standard doesn't even intersect at all, right? And like there's like the cost of doing like that social coordination of like saying, hey, yeah, we're going to get the entire ecosystem together, like that's like it's much harder, right, than like just doing something smaller. But then for the cross-chain trading use case, I think so the big difference in what you get for like layer 2 to layer 2 versus what you get for like layer 2 on chain, right, is basically the trust level, right? Because if you do something that's like fully off chain, then you need to rely on some kind of oracle to actually prove that like something happened on the destination chain, right? I think having that share formats is like something that I definitely think would provide a lot of benefits. So I think it definitely makes sense to have format, to have a shared. Eventually get to shared entities that have formats that can be like as chain agnostic as possible. But then on top of that, I think we also need like an inner layer of standards that's specific to layer 2s, so that you can actually get the benefits of for like making sure that like cross-chain operations are trustless, for example. There's long-term ideas that go even further than 7683 that were like basically get ideas where you can actually have like natively cross layer 2 tokens, and for that to happen, that basically only works between layer 2s that all commit to the same chain within MSR, right? Because basically what the way it would have to work is like every layer 2 would have to make merge blocks with the same layer 2 within which balance this, right? Like this is an idea that I've heard from Justin and SoundLab, other people recently. So if there's like standards that are like that, and then another example is like if you think about one of the ideas for 3770 is that instead of using an off-chain registry, which is like it was totally fine back when we had like 10 chains, but it's not very socially scalable now, like actually using an SF registry, right? And then like the level of Ethereum connectedness you need to have is like you need to have an ENS name, right? But you can have an ENS name and still be a sidechain. You can have an ENS name and you can at the same time have a totally independent ecosystem. So it's so like that's again it's like a lower level of like Ethereum connectedness, right? And that's something that like Binance Smart Chain, I don't know, they might not be willing to do, but like Gnosis Chain, for example, right, they would, right? Because they are in terms of their vision, they're like somewhat Ethereum connected, but they're also not they're not trying to be a layer 2 or anything like that, right? So and then another example kind of on the other side, right, is that there are lots of things that are like very unambiguously Ethereum layer 2s, but then they don't even use EVM, they don't even use CBSA, they're like fuel and UTXOs, right? So I think ideally standards would be like as modular as possible, and chains that are compatible with each other along one set of criteria, and would be able to share the standards that make sense for that, and then chains that will still be able to share as much as possible as well.
I want to ask, there's like purple trees and stuff like that. What's your vision for solo staking in like maybe 3 or 5 years? Like, everyone with a decent amount of ETH, running the validator or something.
Okay. So I think so there's a couple of related questions, right? One question is like what is a level of actual benefit to the network that is like solo staking and small staking can realistically achieve. And then another question is what are specific things that we can do to start from the status quo and improve things for people. So I think for the first question, so this is a recent belief that I've had, right? But I'll throw the idea out there. I think we should increase the quorum threshold, like the percentage in the sign off to finalize a block, from 2/3 to 80%. And I'll explain the reason why I think this. Basically because, so first of all, if we realistically, the cost to liveness of that happening is actually not very large, right? I think the Ethereum network, it only had one outage that goes below 2/3, and I believe we actually might not have even had any outages that are in between 2/3 and 80%, right? Or if we did, maybe we had one. And so the cost to liveness is not high, but then the benefit to safety, right, is basically if you imagine a bad situation happening on Ethereum, which two cases. One of them is software bug, Gap has a problem, but never mind, consent is failure. And then the second scenario is actual 51% attack. Then the less bad thing that can happen is finalization stops. You have a consensus failure, you actually have 2 competing forks, right? The reason why that's less bad is because you have 2 forks, but because it's not finalizing, you're giving users the information that hey, these are right now unstable chains, and people who need a higher level of safety, they would already have written code that waits for finality, right? And then that actually meanwhile, if you finalize something wrong, like then that's like actually much harder to recover, right? And so, like, I think having a wider space where the outcome is that finality stops for a period of time is like actually safer. And so the reason why this ties into staking is that I think getting solo stakers to 51% is like right now it feels like an extremely far away goal. And like I definitely don't want to like hinge the Ethereum and like staking decentralization narrative on a vision that we can get to 51% solo stakers if like right now we don't have a credible roadmap for getting to there. But what we can do is, let's say we set the threshold to 80%, and then we can get to solo stakers and smaller institutional stakers. So let's say I am token staking with their treasury up to 21%, right? And then if we get that, like if we can get a highly independent group of people that's like at least quorum voting, right? Then like in a world 10 years from now, like where the Ethereum is not run by like these like idealistic people that all believe in censorship resistance and the values, but where you have big finance companies involved, and we can't trust the social layer for everything. Like if you at least have a very independent set of people who are blocking, then like that reduces the chance that like something like the censorship attack can succeed, right? So that's like the goal that I think is like both like it feels to me like that's the goal that kind of strikes the balance of being like both like actually very meaningful if we get to it, but also actually achievable, right? So that's one part. But then the second part is like, how do we try to be more friendly to solo staking and small scale staking? And I've asked the question in many situations. Basically, I think the boring question to ask is why do you think more people don't solo stake? Is that like puts you into this like very abstract form mode? The right question to ask is why don't you solo stake, right? And the question that I get is the answer that I usually get is that basically like the number one thing is actually 32-week minimum, right? Like 32-week minimum is it gets more hands than everything else combined, right? And then number two is technical difficulty, and then number three is like all of this fancier stuff of like, oh, he's staking when it can be with like DeFi yield or whatever, right? And so priority number one, I think, is like, so I actually think there are some really interesting strategies to reduce the staking minimum, right? And this has to do with Orbit SSF. This is one of these new staking ideas that got published on the research about a month ago. Basically, the idea is like it's like a random sample community scheme, right? But it's a random sample community scheme that's designed in a way that also has the properties that you need for a chain that has economic finality. And like if this works out, right, then potentially you could go all the way down to like making the staking minimum be 1 ETH without even needing new technology, right? So that's so like this is like one of those things that like I would actually love to see happen, right? And this is like actually one of the topics within the Ethereum research group that's happening right now. Then the second topic then is about staking hardware issues, right? And like I do think that historically, like we have a tendency to focus on the hardware side too much and say like, oh, if we have statelessness and Oracle, we can stake without a hard drive, and that's amazing. But like actually, the gains not needing a hard drive are like not very high if the bigger limitation is like $100,000 a week, right? And so, but I think a top priority is finding ways to like knock that minimum down, and then second top priority is also loosening the hardware requirements somewhat, and then continuing to like find ways to like make the staking experience like easier, even just on a pure UX level, right? So like things like that node are good, right? And there's a lot of these other things that are good, but like I think there's also like a big like social part of the question of like how do you actually like encourage and motivate people to like actually get like put their coins into a staking box and like, realistically do the effort of like babysitting every time like the notification alarm beeps and like something happened with the internet connection or the needs an upgrade or whatever.
So
Yes.
question about the privacy shielded transaction landscape. We've seen a few swings at that before. We saw Secret Network and SGX might get pushed with their limits, and we've seen some VMs try to build from the ground up for ZK primitives. Quantum's going to wipe out a lot of the big-based pairing friendly stuff. So, where do you see that going? Where do you invest?
I feel like the privacy space has kind of turned into at least like 2 or 3 different spaces, right? Because if you look at a lot of the stuff around, like especially privacy that starts going beyond ZK-EVMs and starts getting into like multi-party computation, trusted execution, environments, FHEs, and all of that stuff, a lot of the time their goal is not traditional privacy goals, which are like, hey, I'm in North Russia and I want to donate to opposition political parties and not go to jail for 15 years, right? Their goals are actually more on the side of like preserving market integrity and like basically like having privacy of people's trading strategies, protecting people from getting front run and things like that, right? And like I think there's value in like recognizing that those are different spaces. And I think, they definitely benefit from some shared technology, though even that's kind of starting to fray somewhat. So I think for like the privacy payment side, right, my own approach, philosophical approach to this right now, right, is like I think there's this big transition that like we as an Ethereum ecosystem need to make from like theoretical and idea driven to like pragmatic and like how to make this a realized benefit for users, right? And my first answer on all twos was basically saying, like, what are some like very simple and dumb ways that we do that for scaling? And for privacy, I think it's kind of similar, right? I think, the question right now is like, why aren't more people using even existing privacy solutions, right? And I think like there are answers to this, but we have to like actually go through the answers and like actually take this very usage focused approach. Like start from basic things, start from just fairly by modern standards, low tech and unsexy things like just having magic ZK roadmap polynomial proofs for payments, and then once we have that, start going one level up from there.
Do you think with the really basic solutions, we're going to run into a lot of architectures that start looking tornado-like, and we're going to run into policy issues that way?
So I actually think, this is the thing, right? The policy issues actually become harder to resolve the more you get into complicated stuff, right? So I can give one example, right? So if you think about tornado-type pools, right, like the current strategy for making them more compliant, right? It's basically this privacy pools approach where if North Korea comes in deposits, you have some deposit delay and then you have some mechanism that flags the deposit, and then everyone except the North Koreans makes a proof that says I'm any one of the depositors, but I'm not the North Korean, and then the North Koreans are the only ones that can't prove it, so they can get any privacy, right? But then if you ask the question let's move beyond an in and out system, and let's actually have a full payments architecture where everything's private, right? And then the problem is okay, let's say for example, you make a payment to me, and you prove that you're not a North Korean, right? And let's say I then have to take those points, and I may have to make a payment to Chang over there, right? But then let's say my own standards for what I want to prove are different, right? Let's say, for example, I also want to prove I'm not, from the government of Azerbaijan, for example, right? And then the problem is that because you only need me a proof that you're not from North Korea, I have no way to prove that my points are not from the religion, right? And so there's this kind of composability thing where if you actually try to ask the question of like, how do you make this design tolerate people having a diversity of different perspectives of like which actors you don't want to associate with, then it starts to become much harder, right? And so, like, basically, like these kinds of problems actually multiply even more once you start trying to like say, oh, we don't just need payments, we also need privacy preserving smart contracts, we also need full privacy preserving DeFi, and so on and so forth, right? And so, like, that's actually my motivation for saying, like, let's start with application-specific things, and like the two things are basically one is like in and out payments, and then two are these like very narrow, not trying to like anonymize participation, but just trying to ensure market integrity type architecture. So then like let's get that to a stable equilibrium, and then go from there first. Yes.
Hi. So I have a question regarding Ethereum roadmap as it relates to the search track.
Okay.
So I see that you have listed a goal of like supporting up to 100,000 TPS. So we at Circle, we work a lot with enterprises that have like hundreds of millions of users.
Yes.
So they care a lot about TPS, but at the same time, they also care about the gas. So what we learned practically that even if certain chains claim that they have high TPS, when you before you even reach close to that TPS, the gas price will surge and becomes impractical for any business to consider paying the gas fee at that point.
Yeah.
So I'm curious that as you think about the roadmap for the search track and supporting that high TPS, how are you thinking about balancing kind of like also lowering the gas cost? And when do you think it will be there will be a date where we could imagine enterprises have like hundreds of millions of users could use like EVM chains to support their frequent transactions?
Yeah, good question. So I think the answer has two parts, because I think like the scalability limitations that people have on L2s today have two parts, right? And so one part of that limitation is that we have just like the EVM itself, right? Because ultimately, like most layer 2s today are copies of Ethereum, and if there are specific software implementations of Ethereum which were designed to run the Ethereum L1, and so they never had a need to be able to process more than 15 transactions within a few hundred milliseconds. And so, like each individual L2 has a hard time going above like a million CPS, right? And so, I think the solution to that is like basically software engineering, and like two kinds of software engineering, right? So one is like the hyperscale EVM effort, right? So there's the effort that the Paradigm team is doing, the effort that the Mega ETH people are doing. There's other hyperscale EVM projects, right? So that's like one type of solution. And if they did the math, right, and like there's no theoretical reason why you can't get like a single EVM thread up to like something in the 100,000 TPS range. Like it's basically a software engineering task, right? And then the second part of it, and then the other part of the solution is that there are non-EVM architectures that make sense for a lot of use cases, right? Like especially for quote enterprise blockchain, which is like I know like a term that a lot of people hate because like it just got totally tried and failed back in 2016. But I think it got tried and failed back in 2016 because we gave people like totally the wrong technology stack, which is permission blockchain, right? The permission blockchains have the benefits of they have all the costs of decentralization because you have to worry about quorums and fault tolerance and stuff being easing, but they have none of the benefits of decentralization because like you're still on a proprietary network, not connected to Ethereum network, and like it's not a trust one like normal trust, right? If like consortiums exist and Swift is one of them, and like people still have the same concerns, right? And so, like, the right approach to do enterprise blockchain, I think, is not consortium chains, it's Palladiums, right? Like, basically, you have your server, you keep your server, and then in parallel to your server, you have, like, a piece of sidecar code that basically just keeps making hashes of your database and proofs of your execution, and just keeps publishing proofs onto Ethereum that basically say, whatever is happening in the database, whatever is happening there is valid, right? And like I think that approach actually, like the one near-term use case that I really want to see is actually get proof of solvency for centralized privilege changes, right? Because like if you think about it, proof of solvency for centralized proof of exchanges is a super important enterprise blockchain use case, right? Because you have coins that they need to constantly prove to their users that they're that they're not being insolvent, right? So, but if you're going to do that, then like your software development path is not start from the leading end or prove it. Your software development path is like start from your existing deployment and write a sidecar that like proves whatever you're already doing in real time, right? So like those are the proof paths. So that's like one part of the problem, right? Which is like hyperscaling execution. The other part of the problem is like hyperscaling like validity, basically, right? And like one part of this is obviously like data availability and the current roadmap for data availability. Like the plan is to try to go up to 16 megabytes a slot, which is 1.33 megabytes a second, and then a reasonably optimal rollup would have 23 bytes a transaction. And so, you divide like 1.33 billion by about 23, and like you get somewhere around like 60K TPS or something like that, right? But that's for rollups, right? If you want to go even higher, then like plasma, I think is like still a very underrated technology, right? So like there's Inmax, this Japanese team, is like one group that I really respect. They actually have like a hybrid rollup plasma architecture where they put 5 bytes on chain per transaction, and it turns out that that's enough to give them privacy and protection against like bad operators in a way of a way that Plasma does not have, right? But then, you're basically dividing 1.33 million by just, like 5 bytes, and then you have, 260 TPS, and then there's like other versions of Plasma that can go even higher, right? And like, if you're trying, do like a blockchain video game thing, then like, you don't need like that high level of security, you just do a Plasma that can go to millions, right? So, I guess, like that's how I see the two tracks this being.
Just quick follow-up. You mentioned that sidecar architecture. Is there a specific EIP or like specific document that addresses that type of design?
I think in this case, like it doesn't even need to be an EIP or an ERC, right? Because it doesn't need to be standardized. Maybe the one piece that does need to be standardized is like if you have these enterprise blockchains and they're giving users like Oracle proofs of their data, then like you want a standard way to prove that, right? And I guess that like ERC proof in 668 is basically already good enough to try to do that. But otherwise, it's like very much a like go off and build your own thing kind of thing, which I think is ideal, right? Because I think as an ecosystem we have some fairly like limited like coordination resources. I think we want to like go spend them on the stuff that we where we agree that it's super valuable, and like where we we want to be unified and not have like 15 competing standards that like actually like pick a few directions and then do a little good job on them.
Thanks.
Going back to solo staking, so how realistic in the future that we're going to keep staking and build our own blocks, which was the reason.
Yes.
How do you see bandwidth requirements changing, and is it realistic to that whole not like this?
Okay. So the thinking back in the 2021 era, right, was basically that like we'll like surrender to this like centralized block building, decentralized inclusionist, decentralized validation vision, and like basically if you want to be a block builder, then like you have to have like 16. You have to have the ability to just like push out 16 megabytes within a couple of seconds. And if you're not that kind of actor, then you become a validator, and then you still contribute to inclusion lists, and so you're guaranteeing like censorship resistance but not ordering. So that was the thinking then. I think since then, there's been this like strong push from the community that like basically saying like, hey, we actually want like stronger assurances, and so we have inclusion lists, right? And then I think recently there's been this like near universal consensus on like multi-inclusion list providers, right? So instead of doing one inclusion list provider versus one, you have like maybe 8 or 16 of them. But then the one thing that's like still kind of like in research land is making a really convincing design, both for that and also for the block building side, that doesn't require you to actually have all of the data, right? Specifically for blobs, right? Because for regular transactions, like it's fine with the problems. And for blobs, the basic like way that all of these mechanisms have to work, right, is essentially that blobs get rebroadcasted, and then you as a inclusion list creator or as a builder, like you can basically sample, and then if the sampling passes, then you trust it normally, right? Like the way that the blob architecture is sort of intended to work from a software or an architecture standpoint, right? Is that basically, you do this like sampling procedure, and that lets you put this check mark on pieces of data, and then from that point forward, you just treat it as you're working with a much smaller number of these pieces of data that only add up to less than a minute. And so on the inclusion list side, basically sample, whether the sample passes, you would add. And then on the final building side, you would do the same thing, right? And the big subtlety of this, right, is that DAS is only secure if you can actually guarantee that enough people are data sampling at the same time, right? So that's the one subtlety that we have to really work through. But that's the style that I think all the approaches are going to end up taking.
Intern has a question.
Okay. Yeah, the question I have in mind is actually a little bit abstract in a way, because I read your post recently about enshrining, what features should we try to do at the protocol level, and what should we just that the community or any other people decide for us.
Yeah.
And an interesting trend is I think what I saw is some level came up, Flash level came up, they will put some new incentive on the table, right? Incentive for validators. Then somehow it shift the whole. Somehow everybody want to join, and then it becomes something we want to solve, because now we feel the players or the Flash bots, they are dominant, or they're censorship.
Right.
They can be censored. Or similarly to LiDAR as well. I'm just wondering, would it actually be? Is it possible in the future that maybe one day we only have all the users are on layer 2, that we have 5 layer 2s or something, and then we start worrying about these 5 layer 2s that are standard, right? Yeah, how will you approach this in terms of when do we decide what needs to be enshrined to the protocol level?
Right. Yeah. I mean, I think, I think realistically, right, this is probably one philosophical difference between Ethereum and Bitcoin is Ethereum doesn't pretends to be a fully apolitical organism, right? I mean, Bitcoin I think is still political, but it kind of pretends to be cool, and you don't have there's no such thing as core developers of gold and submit PRs to reach in how the outer electron shell works, right? I think in any crypto ecosystem, right? If there is one part of the stack that's really not working for a critical mass of the community, and people are starting to get existential fears that hey, this is starting to violate really basic properties that are why we came into the whole space, then there is going to be a strong push to try to do something new with that protocol layer to try to resolve that, right? So I don't think that can 100% go away. I think the things that we can do today are, one is being proactive on the research, right? And basically trying to think of as many problems as we can ahead of time. And then the other is to try to be proactive on setting good standards and expectations for what layer 2s can do while they're still small and while they're still relatively aligned, and while there aren't much more powerful forces that are breathing down the nose, right? And so I think in the layer 2 case, I also know, this is a big part of the reason why, Justin is a big fan of basic roll-ups, right? Because, Justin basically wants to just do Ethereum-wide shared sequencing that includes as many layers as possible, and then if Justin's vision succeeds, then, basically any layer 2 would just automatically inherit the censorship resistance of layer 1, for example, right? So that's, one, example of, in that vision. The other approach is basically that, the more modest thing, right, is basically these bypass channels, right? Where basically the layer 2s would, in the layer 2 contracts, they would specify an alternative way for people to send in batches of transactions, and then those just have to be included when the next time that someone publishes it, right? And so from what I've seen, there are roll-ups that already have these bypass channels live. When roll-ups are not willing to include them, the reason why they're not willing to include them is that a lot of the time they're actually pretty lame reasons. And what I mean by that is in the case of ZK rollups, for example, right? A lot of sometimes the reason is basically that they there's some operations within the L2 that are very difficult to prove, but that are not expensive in terms of gas. And so you could have someone send a transaction through a bypass channel that just ends up being too big for them to prove, right? And the reason why I say this is lame is because there's a proper way to solve this problem. And the proper way to solve this problem is that you should basically, layer 2s need to adjust their gas schedule so that things that are expensive for them actually are expensive in terms of gas, right? I think there's coordination work that we can do to actually solve that problem, right? And this is part of why, I published in EIP to readjust some gas costs. So there's discussions to try to make some of that into RIPs. There's a lot of benchmarking happening, right? So to the, I think there's a lot of cases where the reasons why L2s are not better at this right now is not because they want to not censor anyone, but it's just because there's these weird other technical things that just are annoying for them. And if we could just come in and help and basically either make it easier for people to have different gas schedules, or instead of provide standardized ways to do certain things or do whatever else, then that's valuable stuff that we can try to do right now, right? Because right now, I think no one is really no one is treating L2s as being the type of actor they're supposed to you're supposed to try to breathe down their neck, right? L2s are actually right now they're still relatively free to do their thing. And of course, as time goes on and as L3s become more and more of a big deal, that's that level of optionality that they have is going to go down, right? And we're going to have to answer more to both political pressure and to their own token holders. And so I think there's a lot of value in just setting and pushing those and reinforcing good expectations and getting good standards adopted very quickly right now to reduce the chance that there's another one of these big scares in Ethereum 2 or 3 years in the future. How do I see MEV become more centralized?
Yeah, because for now, the red player is for up,
Right.
Yeah. So if you look for or that, get more than that, and
Right.
after that, it will only one.
Right. Yeah, and so there's a couple of solutions to this, right? One of them is, and there's obviously this and multiple concurrent proposer and CP approach that some people are mass resting and those people are trying to push. And that approach basically said, like, it basically tries to make the public mempool mandatory, right? It basically tries to make it so that, like, it's not even valid to include a transaction and just do not go through the public mempool process and, like, done in through, like, regular priority bidding. And there's, like, a lot of people who are skeptical of that approach because there's just, like, too many ways to get different kinds of side channels. And then there's, like, various positions in the middle. So that's, like, what type of answer, right? And then the other type of answer, of course, is to basically say that, it's like right at the application level, try to find ways to make order less relevant within a single block. And I think there's like interesting ideas here that have been kind of underexplored. And one of the things that we can actually try to build on top of is actually ERC-4337 aggregation, right? Because so if you think about the way 4337 aggregation works, right? Basically, the idea is that you have like n different transactions, they have n different signatures, but you don't want to verify n signatures n times. You have like some procedure for combining the signatures into one, and so you verify only once and you say yes, right? And what you could do, well, what this also is, right, is that you could basically use the same mechanism, except instead of using it for signatures, you would basically use it to essentially process all transactions that have to do with some particular application in a block in an order independently, right? And so if you do that, then like that also like reduces a lot of authority from like what really actors are that are actually controlling the rate, right? So like that's another example of a solution. And then obviously the third approach is to basically say that like it's like basically status quo and just saying the losses are not that bad and like basically focus on trying to maximize censorship business, right? So like that's how I see it with 3 of the past we're working in, but I think there could be more, right? I think this is one of those spaces where I think people would actually really welcome a lot more approaches being proposed and discussed.
So can you explain again why signature aggregation is this?
Right, okay, so I don't mean signature aggregation, I mean like the technology that supports signature aggregation inside of ERC-4337, right? Because like, so the way that it works, right, is that you have like these different user operations, and then if they use signature aggregation, then like what happens is that there's there's like a validation step that's like per transaction, but then there's also a validation step at the end, right? The validation step at the end is meant to check some kind of aggregate signature, right? Like this is how like BLS wallet works and like all these things, right? And so the idea is like, what if instead of having the piece of the end be something that verifies signatures, you have the piece of the end be something that just executes the entire market ledger, right? And so basically what you have then is like you have order independence, like execution, at least within one type of application for at least all transactions within a particular block. Yeah, I mean, okay, so Schnorr signatures, the aggregation is 2 rep, right? Like all the participants, they need to talk to each other, right? And so I think for that reason, like, I generally consider it like, it's like okay if for a kind of like a poor man's multisig type of use case, but for saving gas between transactions that were made by different users, it's not really viable, right? Because like different users, they have different wallets, they're not going to talk to each other in real time. Yeah. Yeah, let's look at these. There's some discussions about the side effects of introducing block space, so higher network bandwidth. I think, so the short-term solution to that is, I think there's like different solutions. There's like a short-term, medium-term, and long-term, right? So like very short-term is that the way that blocks are distributed, even right now, is like very suboptimal, right? And like there's a lot of just like very pure peer-to-peer optimizations that we can make, right? And like one nice thing that we have that we can build on top of is that blogs already have erasure coding for free, right? And so we can do things like if you have 32 peers, you can like take the entire 2x blob and you can just broadcast, 1/32 of the blob to like all the different peers, and then you only have 2x overhead and you still have a lot of redundancy. And then as soon as you get 16 pieces, you reconstruct the blob and you broadcast, right? Like there's a lot of these like more advanced strategies that are like actually not that many lines of code because we already have all the infrastructure for erasure coding set up because that's how blobs work, right? So like there's stuff like that. Then PeerDAS, right? So PeerDAS basically lets you verify blobs without having to download the whole thing, and that's the plan for how we scale from the current approach, which is targeting about 3 to 4 kilobytes to targeting like 2 megabytes, right? Basically, every node only actually reprocesses sampling, download like maybe 5 or 10% of a block. Then, and then after that, I think like there's like going to full DOS, and then the question I think like splits in half between verification and like block production. And then verification is the easy part because that's what data availability sampling does, and then for block production, that's the question that I answered before. How do we make math more decentralized? And we talked about this. Account-based model versus SUI networks objects. Okay, so yeah. Hello to you too. How do deterministic sequencing and order-agnostic applications work together to reduce math in other situations where both are needed, right? And then what happens to multiple proportional builders handle transactions when some builders try to censor, and would it be like, these are kind of 3 questions, but they're related, right? Basically, yeah, like would it be better to fix any problems at the application level instead of changing the protocol? I think this is an interesting one, right? I think like my answer is definitely, in many contexts, yes, right? Like I think if you have an application that like leaks NAV revenue, then like that's not just a centralization externality on the network, like that's a cost that you are paying as an application developer, right? And so it's in your interest to try to find ways to reduce the NAV exposure. And so I think, I've like come up with some designs for like versions of Uniswap that are more sandwich resistant. I think Dan Robinson actually, re-upped one of those from like 4 years ago recently. There's like things like CowSwap. There's like order independent execution designs, which I like talked about. I think like I'm super in favor of exploring all of that stuff. In other really important spaces, liquidations, right? There money and other sorts of debt. There's ways to try to make those be like less dependent on being the first actor. So I think it's like good to do those things, but at the same time, there's like limits to how much we can do those things because it's like at the end of the day, if you have an on-chain order book and at the same time off-chain exchanges and off-chain price discovery exists, then like there's always an arbitrage opportunity with someone who has the ability to like add things into a block book like after everyone else, right? And so I think some of these application layer techniques, like they can reduce NAV, but they can't like fully solve the problem, right? And I think like that's the reason why there's a desire to try to make the protocol more robust to that, right? And then on top of that, there's just people who are going to be completely crazy, right? It's like no sane protocol designer in the world would have proposed that like monkey sale that happens back in 2022 that just like spiked gas fees all the way up to like I think literally over 9,000. It just burned $180 million of fees within a day. Like, do you guys remember that? Right? But like no sane protocol designer would ever recommend that, and yet it happened, right? And like Ethereum needs to be robust to like keep on doing crazy things because it's a permissionless blockchain, and so I think it's like the application like side minimization is good, but like the protocol side minimization I think is like also necessary. Well then wait, the question's black hole replaced. Okay, fine. how far does FHE go into practical applications? I mean, this is so I feel like FHE is like the kinds of applications that it targets ends up being like very different from the things that ZK-SNARKs do, right? And like sometimes they're separate, sometimes they're complementary, which I think is really interesting, right? Basically, yeah, because what happens is you like ZK-SNARK based applications, they have this limitation that the only kind of private state they can handle is private state where the owner of the object has the private information. There's like always one person who has the private information, and that's the same person who actually has the authority to like actually send a transaction using that thing, right? With FHE, generally, one of the challenges is like you still like either it's like a two-party compute model where you're trying to solve a very different kind of problem, or you're basically using it as like a type of MPC. And then you have an M of N trust assumption, right? And like M of N trust assumptions are risky because like the big difference between M of N trust assumptions with using like threshold anything and like 51% attacks is that 51% attacks are extremely detectable, right? Like if someone does a 51% attack on Ethereum, one, it's like obvious that a 51% attack happens, and that just hurts everyone. Two, it's obvious who participated, and so you can be slashed. Or someone can start a minority soft fork and you get inactivity, right? It's like very risky and very expensive. But if, let's say, we have a system where everyone's coins are inside of, like some kind of, like M of N MPC thing, then someone could like go to 51% of the participants and they could get them to say, hey, like install this like extra thing, and then if they do that, then it would be undetectable like which of the participants participated, and it could even be undetectable that an attack even happened, right? Like, and so like that's something scarier. Like it's scarier, especially if you shift your mental model from like the M of N being, like friendly, hippie, happy, aligned Ethereum people to be like mainstream major corporations, right? And it's like, if you imagine like Apple, Google, and like Microsoft, they're like doing a 3 of 5, being part of a 3 of 5. Like, if the NSA really wanted to, like, yeah, they could totally, like separately backdoor all 3 of them, right? And so that's like. So that's like the reason why I don't want to lean on the end of that assumption too much, right? Like I think there's ways to make it stronger, and you can like lay your trusted hardware on top and so on. But like this is like to me, the gold standard is like not having like that kind of end of that assumption at all, right? But then at the same time, there are applications where it's unavoidable, right? Basically because like there's applications that just inherently involve doing combined computation that combines multiple people's private data, where you actually have to like combine the underlying data, right? Like you can't decompose it into separate ZK-SNARK pieces, and so you have to do some kind of combined compute that's as close to a black box as possible. One example of this is ZK voting, right? Like if you want to take something like Macy, and then you want to try to make the coercion resistance based on a trust assumption that's like as minimal as possible, then the best thing you can do is basically put like the Macy decryption piece inside of an FHE, right? That's like the best thing you can do, right? And then all of the properties other than coercion resistance, they're unconditional, right? Because you have encryption, you still have ZK-SNARKs, you still have blockchain sensitive resistance, but like just the coercion resistance piece becomes dependent on this FHE assumption, and like that's kind of unavoidable, right? Or another example is like some of these financial market integrity use cases in like a combinatorial auction, right? And in that case, it's like, well, if 51% actually start colluding, then is it actually that bad? Like it's bad from a market integrity perspective, but like at least people in Russia that are like trying to donate to political opposition are not going to go to jail, right? So it's like a somewhat lower level of trust required, and so I'm like more okay with that event there.
If we're looking at the problem of censorship resistance, and that's our goal, and we're looking at this new L2 landscape,
Yeah.
and we think that we can do it cheaper and more data at similar levels of censorship resistance. How would we approach that problem? You get published from many different L2s and many weak networks form onto a strong way.
Yeah.
So,
Right. I mean, I feel like publishing to different L2s is like probably not like that's definitely not the ideal architecture, right? Because the ideal architecture, I think, is that L2s should just all individually like have some kind of like strong multi-proposing, and like each of them individually should be censorship resistant enough to satisfy our standards. I think in the world of today, where we have like lots of centralized sequencing and it's like not great, then if I was designing like say a ZK voting application and wanted to like really crank censorship resistance to the max, then like I would have the the ZK part like walk over as many L2s as possible. So if you want to, you can submit your vote to any single one of the L2s, and like that actually does like you're basically using like multiple centralized L2s essentially as sequencers of sort of like a meta L2 that you're constructing, and like that's actually a decent approach. So I think like if you're trying to be pragmatic and like give people guarantees in the short term, absolutely. I think in the long term, we do want to make each L2 individually secure enough to satisfy the properties of the flow. Okay, Morpheus. Future scalability solutions, particularly with the implementation of sharding and rollups, how do you envision the integration of these technologies and improve the overall performance user experience? I mean, I feel like we already kind of know about rollups, right? I feel like we've kind of talked about this topic of like making rollups have the benefits of the like the 2017 sharding vision in terms of unifying UX. I think the other thing that's important to also talk about is there are scaling solutions other than rollups, right? So like as I mentioned, plasma I think is a very underrated category. And I think like L2s are not just a scaling strategy solution; they're also in in execution experimentation solution. And so, like it's good that we have Fuel. It's good that we have Aztec. It's good that we have CA Sync Light, and like it's good that we have Inmax, like that whole spectrum of systems. So, like I think. The goal of the L2 ecosystem, right, is basically to like strike this balance of like enabling a lot of this. Like right now, like it's experimentation, and then 5 years in the future, it's like specialization of what makes sense for different use cases, but then still at the same time, like being as standard as possible where the standards make sense. Oh, there we go. Oh, okay. Now leave the grid disappear. Well, no, fine. Let's see. How do I view future of social networks? What's the future of social networks? You don't know. Okay, well, I mean, it makes sense that you don't know, right? That's why you're building Firefly as a multi-client, and so you can like tweet on Farcaster and Lex and Twitter at the same time, right? Yep. I think. I mean, what do I think the future of this sort of stuff is? I mean, I feel like the next step in like things like Farcaster and Lens becoming more successful is like they need to go further in offering features and functionality that like offering some kind of benefits to people that Twitter does not offer. And like I think it has a little bit of that because like it has when Farcaster has channels, they just have a different culture in terms of the kind of people who post. But and then like you have this like very idealistic benefit that you have like different clients that are still sharing the same network. Like I think what I would want to see is people like really asking the question of like, well, how do we extend these things so that you can do stuff that like you can't do on Twitter today, right? So like one example of this is like I think it would be cool if something like the Ethereum Magicians Forum was just built on top of Farcaster, and so you could actually have, like some kind of merged discussion where like people would still interact with it through that interface, but then at the same time, it would automatically become something that you could talk about through a Farcaster channel. So there's like things like that. I think there's like this whole question of like, is there something useful that the space can do in terms of the like financial incentives side of things, right? And like, I know like, like social fi as a category is like incredibly cringe, and it's like, there's been a lot of things that just only really make sense in the short term, right? But it's, I think there's still the open question of like, is there a version of that kind of stuff where you've been compensating like content creators and like actually like make sense that it's something that can like really be stable for 5 or 10 years. But I think I feel like the space hasn't quite figured that out yet. But if it does, that would be really cool. So there's that. Yeah. Surprise. Okay. Yeah. The timeline of Stateless. Oh, that's. I mean, this is an interesting topic, right? Because this is one where like a lot of my thinking has been like shifting a lot recently, right? Because I think the default path for a long time has basically been, okay, we have Petra, and then right after Petra, the next hard fork is reserved for UN protocol trees. I think there is, in my opinion, a good argument for like actually revisiting this. And the argument is basically a combination of two things, right? One thing is that if you actually like ask, what are the pragmatic benefits that protocol trees are supposed to provide, right? Then one of them is, okay, you should be able to stake without and like run a node without a hard drive, right? But then their state is only half the problem. The other half of the problem is history. And so we need 4444 to implement it first, right? Then the next question is, well, what's the underlying goal behind staking without a hard drive? The underlying goal is making staking more accessible. Well, is staking accessible if it requires 32 ETH, right? And it's not. 32 ETH costs, like way more than a hard drive, right? So if I have like this laptop here, it's got a ref archive node on it, and like the full 2 terabytes, and like actually like Shelley here helps quite a lot in basically like going into like the fancy electronics parts stores here in here in Taipei, and like upgrading the 32 gigs of RAM to 64 gigs, so you can also run the 7B models on it, and then also like adding a 4 terabyte hard drive on top of the 1 terabyte, and like that stuff altogether costs like $400. So this laptop costs $2,000, right? And then guess how much 32 ETH costs, right? Well, it's it's back under $100,000, but still, it's like 80,000 right now, right? And so, like basically, if you like think about underlying goals, right? Then like basically, reducing the 32 ETH minimum is one example of like a different thing that you could focus on, and so. Like, I think there's a big question of like, well, maybe, there's value in like delaying Vertical by one more fork and like actually, like saying, let's like prioritize other decentralization related tasks a bit ahead, right? And like one example of that is like reducing the 32-ETH minimum. Another example of that would be on the execution layer side, doing account abstraction kind of right and like getting to the point where we actually have some kind of enshrined abstraction for the validation step. Like this, we can think about this, right? Then, so that's one part. And then the other question is like, I think there's a lot of like hidden costs that core apps don't like naturally recognize in especially core researchers. I think core devs recognize more, core researchers don't, right? In like constantly rejuggling pieces of the protocol, right? And like saying, we're upgrading the protocol and then later we're upgrading to something else, right? Because it's like every time you change a piece of infrastructure, the Lindsay counter resets to 0, right? And like there's lots of applications that have to upgrade, and then the possibility of core infrastructure changing means that more applications have to have upgrade switches, and then more solo stakers have to upgrade infrastructure. There's like all of these hidden costs that like harm Ethereum's ability to become this like incredibly neutral like global settlement layer, and so if we want to optimize for that, then like the challenge with Oracle is that eventually quantum computers are going to come, and quantum computers are going to like make anything based on what the curve not viable anymore, right? And so the other path that we could take is we could say, well, how about we skip Oracle and you go straight to starting binary hash functions, right? Like basically get, and within that design space, there's like a trade-off, right? Which is basically you take an aggressive hash function and then you do a start on that, right? Like if you take Poseidon, like you can do 500,000 hashes a second on the laptop already, right? Or you would take a more conventional hash function like Blade 3, and then you can prove like maybe 30,000 hashes in a second, right? But like even still, it's like you optimize that a little bit more, or maybe like you kind of do some kind of meeting in the middle of those two approaches, and basically get within maybe 3 or 4 years we can get to the points where like we would actually feel comfortable ossifying the Ethereum state chain, right? And like if we say we ossify the Ethereum state chain, we actually make a hard commitment to the community that like we are never changing this again unless there's like actually some like big security wax one, then that would make applications developers comfortable with like, for example, doing applications that like within L2s that directly be proofs that are on L1, right? And then like there are other ways to do this. Like you could theoretically have a briefing model that like upgrades if the state tree upgrades, and that's something that I was pushing hard 2 years ago, but then it turns out that actually doesn't work. The reason why is because there's lots of applications that do these state proofs inside of a state, right? And so like basically it turns out that like, well, actually the biggest gains do basically just come from like actually ossifying the state tree, right? And so if instead we get prioritize other things, and then we instead ossify the state tree and like we do all the statelessness stuff on a somewhat more delayed schedule, then like there are benefits to that, right? And I think it's like really worth it for the community to consider the different trade-offs of these two different paths.
Okay. Is BDF still
But yeah, I think I feel like right now it's kind of on standby, right? Like there's people continuing to research BDFs. It's still an open question of like, is there a BDF that we could actually become confident enough in? And I think if we do discover that, then like eventually, well, I think there's a good chance that we'll put it in. But I think right now it's like one of those like open question marks. Yeah.
麦轩可以再讲一次吗？拜托。可以吗
I saw the delayed encrypted network in your roadmap, and I wonder if it is used to resist or
Yes.
censorship or NDBs and that's
Yes. So I guess I view delayed encrypted mempool as being like in the same category as like some of these like multi-confirmed proposal type solutions, right? In the sense that they try to like remove almost like many kinds of NDB strategies from the space of things that are even possible to do, right? Because like they basically say like everyone is going to publish transactions that are encrypted until like basically after they were already committed to, and then get decrypted, right? And so like this like ends up solving a lot of like private workflow incentives and all of these different things, right? I think the one big challenge with that stuff is technological, right? Which is basically that like delay encryption is like kind of almost the same technology as EDFs. Like it's not quite the same, but it's in that same space. And so we need to have a construction that we're actually confident in.
I have my question is more like relate to ZK-VM or EVM. So my first question is, you wrote a post about multi-client philosophy.
Yeah.
Yeah, so I would like to hear more insight about this idea.
Yeah.
And yeah, sorry. And the second one is about the proving system. You mentioned stock in many of your posts in the tweet, and we all know it's quantum resistance. But there's a major argument in the field is stock is not its security is not fully verified. So I would like to know your thought on this security issue.
Okay. Okay, so on the multi-proving, I think, so the idea is, right, that Ethereum has this multi-client philosophy where we have multiple implementations of all of the pieces of the Ethereum stack, and so, that both, reduces power concentration in one group of developers, and it also makes sure that, if one of the clients has a bug, then, that bug doesn't take down the whole network, right? And so, I think the question is if we start incorporating ZK-EVM into layer 1, and we start to make big parts of Ethereum dependent on ZK-EVM at layer 1, then it makes sense to have multiple implementations of the ZK-EVM for basically the exact same reason, right? So that's basically the philosophy there. On the Stark security side, so the way that this works, right, is that basically, so the security of a Stark depends on the number of branches that you do at every level of Fry, right? Like the number of different queries that you make, and you get a Merkle branch for each one. And basically, what they have is they have an unconditional proof that a Stark is secure if you use a certain number of branches, but then Starks that are in the wild right now, they generally use 2 times less branches. And they have only conjecture-based arguments for why this is secure, right? And so basically there's this 2x gap between Starks as most people deploy them today and Starks where we actually can prove that they're unconditionally secure. The gap is only 2x, right? And so if we deploy them at layer 1, I think we should just eat that cost and we should just make Starks 2x bigger.
And a quick follow-up question. What is your expectation? How many years the ZK-VM or EVM can replace the current execution layer?
So I think the big milestone that I think we are shooting for is that we want a ZK-EVM that is fully formally verified. Right, so we have a very strong formal verification effort that's really starting right now. That's been running for a few months and already starting to make quite a bit of progress. And then 2 is that gives proofs in real time, right? Basically right now ZK-EVMs generally take 10 or 20 minutes to prove a block. And we want a ZK-EVM that can prove a block in less than 1 or 2 seconds, right? Now that does not mean prove in 1 or 2 seconds on this, right? What that means is it's okay to require 300 GPUs, right? What it means is take advantage of parallelization, right? Basically split up any EVM block into, let's say, 1,024 pieces, have a different proof for each of those pieces, and then have a tree of aggregation, proofs on top of proofs, right? And so then the time that it takes to make that proof is only log n, right? The resource requirement is O(n), the time is only log n. What we have now is we have things that do one layer of recursion that can prove average Ethereum blocks in 15 seconds, right? So that's average case and not worst case, and it's 15 seconds is still being 10 times more latency than we want, but it's getting pretty close, right? Even 15 seconds, that's already good enough for a light client, right? So I think if we can get those 2 things done, then we can get to the point where Ethereum clients, not just validators, but also even light clients, right? What I want is I want a future where even mobile clients and MetaMask and browsers and IAM token they're not just trusting RPC providers, they're like actually fully verifying Ethereum, right? And like to get to that, I think we need, one is we need statelessness, two is we need all of this layer 2 stuff, and then 3 is we need fully functioning layer 1 ZK-EVMs. For how long it takes to get there, I think maybe, I actually think we'll have tests for we'll get there within 3 years. That's one guess. I think
Hold on.
ZK-EVMs are like the one technology that just keeps outperforming our expectations.
How are you formally verifying it for construction? Or?
So there's a couple of approaches. So the way that all of the ones that I see work is, so what they do is they basically they prove a much more minimal VM. Like generally it's like the 2 that I know about are Pyro and RISC-V, right? And then they basically formally prove an implementation of the EVM in that VM, and then they prove that it's equivalent to something like, the pre-existing EVM with these semantics, right? And then for how you do the smaller thing, there's what you're trying to do is you're trying to prove that the ZK arithmetization actually matches the VM architecture, right? Well, the VM state transition function, right? And there are some approaches that are correct by construction. There's some approaches that actually try to make a proof in lean. So they start from an existing outlook implementation, they try to prove it. I've seen some of both. Yeah.
So this question suggested by Yashin perhaps. So in order to achieve account extractions, there's wallets that are willing to adopt signers from the outside world.
Right.
And there's some Yankees that suggest we should enshrine new crypto curves, namely SCEP, R1 stuff.
Yeah.
But it is it was intentionally avoided by Satoshi Nakamoto because he suspects that is backdoored by some three-letter agencies. So I'm wondering how you view this kind of potential conflict, or let's say what if in the future people want to further enshrine some less secure crypto primitives.
I think this is the reason why, I don't, especially at L1, I don't want to keep enshrining application-specific cryptography, right? The thing that ideally actually wants to do is it wants to enshrine some minimal piece that's powerful enough that you can implement other cryptography very fast on top of it, right? And so for that, the 2 existing efforts that exist, right? There's Max, which is the modular arithmetic extensions, which is on top of ELF. And then there's the SIMD EIP from Greg Golden from many years ago. One idea that I've been talking to with the authors of Max is basically I think we should combine Max and SIMD together and basically make one EIP that just does modular operations on multiple inputs at the same time and do this in a way that's as optimized as possible. And then if you do that, then that makes hash functions Poseidon much faster, and that makes curve operations much faster, it makes lots of things much faster, right? There's no good theoretical reason why it needs to be more than maybe 2 times slower than a precompile implementation, right? I think even with our experience with precompiles so far, there's lots of precompiles that just don't get used anymore, right? And so I think because of that, there's very little appetite at L1 to keep adding more precompiles, but if we actually can add something that's generic, but that's still powerful enough, that you can implement both R1 and quantum resistant cryptography and whatever else you want on top, then that's something that could be very compelling. Yeah.
What's your take on economic security is a mean?
On the economic security of
It's a mean.
Of what? Sorry.
It's a mean.
ETH admins?
It's a mean. It's a mean.
Oh, the economic security of ETH as a mean.
Economic security is a mean.
Oh, it's a meme. Oh, that topic. Yeah. I saw some of those discussions. I think, basically, the reason why I think like a lot of that is not true, right, is that I think a lot of the, it's not true that economic security is just a meme, is because a lot of the time what some of those discussions do, and I know this is like people in, like Avalanche and Solana and other systems, like some of them say this, right? They say like, oh, if something bad happens, then we just slash socially, and like the social layer figures everything out, right? Is that like, I don't think that we should trust the social layer that much, right? Like, I think there's things that we should, that like, there's places where I think like the Bitcoin maximalist approach just like doesn't, it pretends to not trust the social layer, but like it actually does, right? And like I think that like we can go to extreme, but then I think the approach of just saying like, hey, let's like just give up and let's like assume if a 51% attack happens, then like a committee of people are going to decide whose billions of dollars claim to burn, right? Like that's like the idea that could go well, I think, is like itself very unrealistic, especially if you think 10 years ahead and like you think of this as, again, like major stakers not being, and like major core developers not being these like very openness and censorship resistance inclined Ethereum people, but being these very mainstream corporate actors, right? Like if you imagine, like Google and Apple and Microsoft having like 40% of the stake, and then if you imagine, they end up being on the wrong side, where like actually they deserve to be slashed. Like, they're going to come up with like very loud arguments for why, actually, they need to be bailed out of the room too big to fail or whatever, right? And so I think actually, like trying to automate the processes of what happens in a 51% attack as much as possible is super valuable, right? And even having penalties is super valuable, because even if it's never certain what's going to happen if an attack like actually takes place, the fact that there is a risk, right? The fact that there is a risk, or like if you're, like even like who report based or whatever else, and like that if you participate in a 51% attack, there's like actual running code that's going to burn your money by default if you do an attack. Like even that risk is enough to be a really strong disincentivizer for people, right? And so I do think that there is like that value. At the same time, I think the place where like that stuff does have a point is that I think the difference between like 1 million ETH of economic security and like 40 million ETH is definitely less than what people think, right? And so this is actually part of why like this is part of the compromise that Orbit makes, right? The way that it gets more decentralization is it basically says, well, instead of making all of the ETH slashable, we're only going to make a relatively small portion of ETH like actually be subject to slashing at any one particular time, right? So you actually make that a different type of compromise.
Yeah, one more question. Is it possible to make the yield for solo stables higher in a way that only solo stables have access to that? Because one issue has been when you buy LCDs, like you can get really good deals on LCDs and DeFi while you're solo staking. You were saying that we want to solo stake, but we need more solo stakers, and yes, it's probably like miracles, we're onboarding only solo stakers. Is it possible for that separate your solo stakers?
Yeah, I think the challenge is like, if you give higher interest rates to solo stake or higher rewards to solo stakers, then like there's always that like the big guys are going to try to pretend to be 10,000 little guys, right? And like they're going to be able to get like basically the same rate. So the question is like, how do you try to beat that? The best that I've come up with is this EIP that we've did some network analysis for and co-authored for with Tony Barstader, which is this approach that's based on correlation analysis. Where the idea basically is that like if you're a validator, you penalize people's mistakes for if they occur at the same time as when other people are making more mistakes, right? And like this is something that we kind of do already within activity leaks, but the idea is to like really do it for like basically every type of failure. And there is some interesting, like if you go through that EIP, you go through the ETH research discussions, like basically what it ends up being is that like the status quo is basically that the most well-resourced actors, they get slightly higher returns because they have they get much better technical setups. But what you get is basically you get this correlation analysis could, or like correlation penalties could reduce the the benefit of being a large staker by like something like I think 3 or 4x. So it's like a pretty big gain, but that's like just from a protocol perspective, right? I think if we start talking about like how you compensate for like this these other forms of like various like DeFi yield, I think. I mean, to me, actually, like one of the most realistic answers there is just like some form of stake capping, so that like basically change incentives to target the amount of ETH staked being consistently lower than like half or some other number of all the ETH, and like basically try to encourage the two different pools of like people doing staking and people like getting DeFi yield to like actually be different, right? Like that's kind of the easiest solution, right? The challenge with all those other solutions is that most of those DeFi projects, they don't just want an assurance that you get slashed, they want like the ability to like actually take your money, right? Like if you think about something like CDP, they want the ability to like actually take your money if you get liquidated, right? And so there's like this inherent trust aspect, and that's something that like source stakers can't get, but that is something that staking pools could get. And so one other direction to try to achieve that is also to try to have more types of decentralized staking pools that try to distribute authority even more than what something like Lido was doing. So that's probably the most that you can do in protocol. And then extra protocol, I mean, obviously, you can have like L2s do airdrops that try to target solo stakers, and then like they're playing a constant cat and mouse game. I don't know, we have felt like big stakers pretending to be solo stakers, and like maybe we kind of embrace the cat and mouse game and say that's just like part of the fun of being Ethereum. Like basically try to give like solo stakers more of a kind of extra protocol benefits. I think is interesting, right? I mean, there's like other fun ideas that you can do. The other one is like, I think if you have a solo staking box, then like you might as well reuse that infrastructure and like run your own local copy of Block 405B on it, and so you have your own like self-sovereign LLM. So like there's lots of these like extra protocol things that I think we still aren't fully close to maxing out on either. So I think it's some combination of both of those. Yeah. Nice. You remember the numbers. Yeah. Yeah. Oh, did we want to finish a few more of the remote ones? Yeah, let's see. The remote. Let's see what the remote one is.
那真是吗？他反手是没有回答。
Integration of layer 2 chains. I mean, I guess like the question is like integration of like it's like what you want out of integration, right? Because like I think like to me the North Star is basically that like layer 2 should be like experimenting today and optimizing for separate goals tomorrow in those dimensions where it makes sense for them to do that. And layer 2 should be standardizing where there's value in having this like Ethereum-wide shared user experience. And so trying to like continue to on the standardization side, right? Basically, like starting with asset transfers and doing like client stuff, then eventually getting into key store rollups, and that I think are like the first things to start from. I think there's like also more of a social element to this, right? Which is like we've had lots of good interop events between Ethereum client teams, but we haven't really had good interop events for wallets, and we haven't had good interop events for layer 2s, right? And so I think trying to like experiment more with different formats is another thing that I'm really trying to do more of, and I think this is also an example of that. Yeah. Okay. On在research 的设计中有包括DAS 这点采样的次数 like just DAS sample count 和完成不认识资料的采效比来对不起我的那个翻译不太好几乎相当OK。Wow. 可以说一说，就是 DAS 这个采样的次数有两个安全，就是有两个安全相关的 considerations。第一个就是任何的一个 sampling 的一个问题，就是如果你 sample 的太少了，那有可能有一个 block， 那个 block 没有50%很大的温度，但是你就是如果你的 sample 就是如果说有一个 block， 那个 block 的49%的温度，但是你的所有的 samples 是在这个49%里面，那就是一个错误的 block， 就是一个你不应该接受的 block， 但是你按照你自己的 sample 会发现这个 block 都有问题，对吗？所以这个是一个比较简单的一个数学题，就是比如果你的 sample count 是一个 sample， 那这个概率就是0.49， 如果是两个 sample 是0.24等等，所以我们大概觉得可能10个和20个 sample 是比较大概安全的。如果是按照那种是 cryptography 的标准，那应该说呢是要128-bit security 的。所以我们原来的那个，就是如果你看我们说2017-2019年公布的关于 DAS 的文章，你会看到我们会说30个或者70个这种 samples，这个都是我们按照一个更保守的一个像 cryptography 的那个 probability of failure， 但是现在这个 DAS 里面我们比较注重一个效率这个问题，所以我们说我们有从大概10个samples 开始，这就是第一个 consideration。第二个 consideration 是，就是如果你就是比如说，如果有一个 block， 这个 block 有100个 samples， 但是每一个节点可能是 sample 会 sample， 我们可以说7个。然后如果只有7个节点在 sample， 其实这7个节点它们一共就sample 49个那个 samples， 所以他们不会到。它的 samples 在一起不会到50，那么所以他们没有这个 recovery 的 block 的问题。所以对第二个问题就是我们希望有足够的节点和足够的 sample count， 这样的话真的不能做这个攻击，就是发布一个那个 block， 然后每一个节点在 sample 的时候，你可以回答，但是其实你可能是公布了49%，然后就进了，对，所以避免这个攻击，其实这个也是一个数学的问题，可以比较简单的一个计算。Ethereum Foundation is a research organization. It specifically speaks itself as a protocol research institution. As a result, it doesn't even have a well-established engineering team, nor does it have the capacity to desire. For example, despite some people believe that Ethereum lacks the capacity to push, and there's even a consensus that if the ETH were to actively participate in the engineering efforts, it would compromise the mission of decentralization. No, this is definitely like a really important discussion that's been happening within the EF, which is basically like what is our relationship to like these big infrastructure projects that are like big and that need to be done and that have that do need like some high level of coordination and standardization, but that's at the same time try to like there isn't like some profit motivated incentive for it, right? And like I think 2 or 3 years ago, the EF's approach has definitely been more on the side of like not our responsibility, with the one exception of client teams, or for client teams we did like pretty heavily seed all of the client teams with some grants. Good. Now actually it's like a lot, like most of them are actually quite self-sufficient and they figured out ways to fund themselves with side businesses, which is like pretty fascinating, right? But before they there's this issue, but then now we're obviously starting to think about these like cross layer 2 standardization things, and so like actually over the past couple of weeks I've been having discussions with people in the EF of like how the EF could have like either a team or an independent organization, and like maybe it doesn't even matter too much which one, that's like much more specialized and like being closer to the user. And like interacting more directly with people that are doing L2s and wallets. So like that's the type of discussion that we've had. Another discussion that we've had is in the context of ZK-EVM stuff, right? Like there's I think a desire to like really take some of the work that the PSE team has been doing and like basically go from saying, like PSE has privacy scaling explorations to PSP, privacy scaling productions. Not PlayStation portable. And like basically saying like, hey, we've been talking about like digital democracy. Let's like actually have like ZK voting that people somewhere actually use. And the question there is like, is PSE going to retool itself into being a much more production-oriented organization, or are we going to take like this kind of like arm's length approach? And so far, I mean, like we're still navigating that, and actually the answer so far has been some of both, right? So like with ZK email, for example, like that's something that PSE has been doing, and that's something that PSE has been like pushing closer and closer to like a production standard quality. And that's something that like a bunch of wallets are already starting to incorporate as a social recovery voting option, right? So that's like one of those like examples of like actually like us getting a bit closer to like actually building stuff that people use rather than just doing research in demos. But then there's other places where there's like specific projects that need to be done, but then it just turns out that like there actually are high quality teams that like already came together for some other purpose, right? And if we can just like work with them and empower them, and like especially if those teams are values aligned, then like the right thing to do is not to like try to eat them like through some kind of apple hire, but to like actually like find ways to like have that like collaborative relationship with all of cross communication. So like this is definitely something where the EF is like very much like in the process of recalibrating itself right now. Yes. Oh, thank you. Okay, see, okay. What do I envision the future of solo staking to look like? I feel like I've talked about that. Do I see restaking as complementary to Ethereum, or something solo stakers should approach with caution? I mean, I think like the caution side of it is basically what happens if there's like the type of restaking that actually involves putting lots of assets at risk. Right, as opposed to like IDD staking, where there's like one component is ETH, the other component is IDD tokens, and actually the IDD tokens are at risk. But like that type of thing, I'm like actually much less worried about, right? Like if we actually start to see these like very large scale, I mean like rehypothecation type applications, then there definitely is potential like risk unknown unknowns if they get too large. But like right now, I haven't seen one that's like that feels like it's like has natural room to expand to be large enough to be a concern, right? Because like right now we have 10 million, like 30 billion ETH that's being staked, right? And like realistically, I feel like all of the layer 2s on Ethereum combined, like they probably decline with like a few million ETH of restaking or restaking security, but obviously that could change in time, right? So I think what we want to focus on, like, take a very application-based approach, is that I feel like the solutions are going to end up being application-specific. But I think the value that restaking can provide definitely complementary with Ethereum. So view the impact of the Ethereum after the adoption of the Ethereum ETF. Okay, so in Paris, there's this like joke that I heard once, which is what's the most beautiful place in Paris to get a view? The answer is Rotemont-Parnasse. Why is it Rotemont-Parnasse the most beautiful place to get a view? Because it's the only place in Paris where you can get a view where you won't have to look at the buildings with Rotemont-Parnasse. And so the quote like here is that I think the biggest benefit of the ETF being successful for Ethereum, I think, is like we don't actually have to like think about the friggin' ETF anymore, right? like honestly, like I feel like it's like it has this kind of like resource curse effects on a community where like instead of the community optimizing itself for either the optimistic values of like openness, permissionlessness, censorship resistance, or decentralization, or the pragmatic value of like, again, like let's make some of these things actually like reach mainstream users in any application category than payments. Like it basically turns the Ethereum ecosystem into these like very like small to like being kind of characters that just like look up to the gods above and like please approve us, right? Like now that that's done, like I'm actually so happy that like, we can actually like focus on the improving things like like openness and provisionalness and at the same time like getting much more serious about like mainstream applications and some of these large questions.